Oh, yes.
Patent pending.
Yeah.
No, it's the wave equa it's not the wave equation, it's the Dave equation.
Love it. Okay. Yeah, actually, you're trying to get this into upper triangle, so you put zeros in the lower triangle. So the first matrix that we're trying to create is whatever we need to make a zero on that second row in the first position. So we'll have our ones in the diagonal, and then we know that we need 2 times the first row added to the second row gives us a zero where the 4 is. Um, the next step, yeah, it looks good. The next step is to, if we check it, if we do capital B, capital A, um, we can see what the combination of our elementary equation times our original equation would look like. And so this is our next step. Okay, so now we have the next position we want to zero out is on the third row, because upper triangle, we don't mind about there not being ones on the diagonal. Upper triangle's fine. Um, so what we would do is -3 times the first row is what would give us a zero in that position for the third row. This is -3 times -2, +6, added to 6, added to -6 rather, and that'll give us a zero there. So yeah, and if you get to that, you go to the next step, and if we do again CBA, because remember we're combining the elementary matrix back to what we already have, which in that last step was BA. Now we have CBA, and we have two zeros. We're liking it. We want another zero where that -6 is. Also, this is keeping us from having to do the math and making any typographical errors. Um, Once again on the diagonal, each elementary equation starts off with the identity matrix. Um, cool, love it. 2 times 3 in the second row will give us a +6. Add it to -6. That should give us a 0. Again, we just add that to their previous. Awesome. Now we have zeros in the lower triangle, or below the diagonal, rather. The way to check, the way to get L in this case is it's the inverse of each of the steps that we took. And the reason that we want to have separate matrices for each of those elementary steps is so that we can take their inverse. So we start from the first step to the last step to find our L. So it'll be matrix B inverse, and then C inverse times D inverse. And so if you see in that diagonal, it's all ones. In the upper triangle, it's zeros. Um, One way that we can double check that we're in the right track is B inverse, C inverse, D inverse. You can times that by what we know of for U. In our case, our U is DCBA because it's A with all of those elementary matrix times it. So in this case, you can just put parentheses after the D inverse, just as a sample, just a testing real quick, DCBA. That should pop us out the original in matrix. And so now we know for certain that we're on the right track. Here's our L, here's our U. Um, the next step with those equations, um, if you don't mind going back to the equation, back to the problem, sorry, because they always want us to do something with it. Okay, AX equals 1, 2, 3. I like to write this stuff down. I like to write it down on a piece of paper just so I could visually see what we're working with. But we're basically using Um, so A is made up of L and U, right? So LUX. Um, so we know in this case we can use UX as a replacement for Y, right? We use Y, and then we're just left with LY equals 1, 2, 3. Uh, that's You know what? We'll just do it in our heads if you want to go back to the or do you have a way to write on the screen? Awesome. Cool. All right. Let's just start with we can do this part completely on the paper. So um let's actually start with AX equals B, right? This is what we know. AX equals B. Um we know that A from our LU decomposition, A equals LU. So let's go ahead and swap out the A back in that equation. So LUX equals B. And if it helps, um, you can put a little, and I usually put a little arrow over X and over B to remind you that both of those are vectors. All right, now with our LU decomposition to helping us solve this, we know that we can use Y as just a placeholder for UX, right? Because the way that matrix multiplication works, you can just take out one piece times by the other, it kind of still works. So Ly, yeah, perfect. You can put parentheses around the U and the X if that helps. Cool, perfect. So Ly equals B. Now Y is a matrix in this case. We just don't know what it is. Um, it actually should be a vector, um, but we'll get back to it. Yes. Okay, so yeah, some formula, L times some formula equals RB, which in this case, B equals 1, 2, 3. So the way that we would isolate Y, staying on this, is we throw the inverse of L to the left of both sides of the equals. Now, um, coming back to Desmos, I don't need it. I don't even, you already have it written right here. So make a new matrix, call it, um, yeah, just, no, actually, this is going to be the vector. This is our vector B. So it's going to be, yeah, 3 rows, 1 column. This is 1, 2, 3. Yeah. Go to the next line. All right. We want to throw the inverse of L at that vector. So let's parentheses because it's going to be its own thing. Open parentheses. And then we know our L was B inverse, C inverse, D inverse. I know it's confusing right there because we put DCBA right after it. Yeah. So we know that's our L. So let's copy and paste it. Yep. Love it. Take the inverse of those parentheses. That is the inverse of L, and then times it by E. That 148. That's our
Woo!
coming back to our to where you're writing it down. Okay, so what we did was we took the inverse of L and we threw it to the left side on both sides of the equals. So if it helps you, write L inverse times, um, no, so that's what's the confusing part. That's not a true statement. Erase the
Hey,
equals
isn't it just like
because
L times L
y equals
inverse?
148. Yeah, so that's why, like, yeah, yeah. So that's why you almost want to you don't have to erase everything. But yeah, y equals no, ly equals 1, 2, 3, right? And then we threw L inverse at both sides of the equals. That's the notation that I like to say. Ly equals 1, 2, 3, and then we put L inverse to the left of the L, and we put L inverse to the left of 1, 2, 3. Yeah, arrows. Yep, left inverse. Exactly. Thank you. Yeah, I forgot the terminology. Left multiply L inverse to 1, 2, 3. So what that does is it isolates Y.
Mhm. Then you just have y equal
Correct.
148.
Now we have our Y. Yes. UX
Wait,
equals Y.
I I thought it was UX equals Y.
Yeah.
Yeah,
Yeah, yeah. It's just you inserted that UX equals Y. And so
because we
what we
just subbed
do
that into the
is we
oh, y.
took the left yeah, go ahead. Yes. Beautiful. Yeah. Yep. So in case it's hard to see, U inverse times U times X equals the U inverse times our Y. Yes. Because our U was our DCBA, like inverse of that guy. What you can do is you can just make a I just make another matrix underneath E. Yeah, a new matrix. A new matrix. Oh, don't clear. 148. Yes.
Wait, what you guys are doing now?
Bro, so if you cleared it all. It should be. So DCBA is our U. So we're taking the inverse of
Mhm.
U, and we're left multiplying that by our Y. Yes.
Awesome,
Noise.
yay.